Hi all, welcome back to Matlab tutorial on Tute Fulcrum. This session is on array indexing. Every variable in Matlab is an array that can hold many numbers. When you want to access selected elements of an array, we make use of indexing techniques. In Matlab, there are three primary approaches to accessing array elements based on their location, or we say index in the array. These are subscript indexing, linear indexing, and logical indexing. Let's start with subscript indexing method. The most common way is to explicitly specify the indices of the element. So let's create an array first. Say A is the array that we are going to work with, and let the elements be 1, 2, 3, 4. Let that belong to your first row. Then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have created a 4 cross 4 array. That is, our array has 4 rows and 4 columns. Let's say we want to access the element 1 of our matrix A. So the index of A is, the row index or the row number is 1 and the column number is 1. So by subscript indexing, if you want to access the element 1, we specify the row number and the column number of the element to be accessed. So in this case, our element 1 belongs to first row and first column. So we specify it as A of 1, 1. So this will give you the element 1 from the matrix A. So let's verify this. So if I write a command A of 1, 1. Yes, it is giving the output as 1. That is, it is accessing the element 1 which is belonging to the first row and first column of the array or matrix A. Let's see one more example. Say you want to access the element 10. So the element 10 belongs to the third row and second column. So we give the command like A of 3. The row number is 3 and column number is 2. So A of 3, 2. Yes, you're getting the output as 10. That is, it is accessing the element that is belonging to the third row and second column of the matrix A. That is, the element 10 is accessed. You can access multiple elements of your array. That is, for example, if you want to access these elements, say 1, 2, 3 and 5, 6, 7. So you can give the command like A of, so here you can specify the row numbers as well as the column numbers. So when you have multiple row numbers, use the square bracket. So which all rows we are accessing? First row and the second row. So 1, 2. Comma, next entity is the column number. So you have multiple columns. So specify the column number within square brackets. So which all columns are we accessing? We are accessing the first, second and third column. So 1, 2, 3. So this will give you the elements 1, 2, 3, 5, 6 and 7. Let's verify. So A of 1, 2, then 1, 2, 3. Yes, you can see your output. It is accessing the elements 1, 2, 3, 5, 6 and 7. Now the same command you can give making use of the colon operator. That is, you can give the command like A of 1, 2. So this will access the first row as well as the second row. Call row numbers from first to second. Same way, column numbers you can give like 1:3. So this will access the column numbers from 1 to 3. You will get the same output. So it's not only accessing, you can modify the elements as well. Suppose you want to modify these values, say 1, 2, 5, 6, you want to modify to 11, 12, 15 and 16. So for that, first you need to access them. So how do you access them? You have to specify the row numbers and column numbers. So you are accessing the first row and second row. So 1 is to 2. This will access the first row and second row, and you are accessing the column 1 to 2. So here you have accessed them. Now how will you modify the values? You just have to use an assignment statement. So if you assign it with 11, 12, then 15, 16. The elements will be replaced by 11, 12, 15 and 16. Suppose you want to access your entire row. You need not write like A of 1:4. Instead, you can just specify the same using simply a colon operator. This is going to access your entire row. Suppose you want to access the first column. So here you can see it is accessing the first column of your matrix. Same way, if you need to access your entire column, say you want to access the first row and your entire column, just simply specify the colon operator. So this will access your first row, all columns. So this is how you make use of subscript indexing technique to access the elements of your matrix. Now let's see another method for accessing elements of an array using only a single index regardless the size or dimensions of the array. This method is known as linear indexing. So let's create a matrix. Let's say B is equal to 1, 2, 3, 4. Let's take a 2 cross 2 matrix. As you can see, while Matlab displays arrays according to their defined sizes and shapes, they are actually stored in memory as a single column of elements. That is, Matlab stores it as a single column like 1, 3, 2, 4. That is, columns will be appended one after the other. So, in linear indexing technique, we need to consider this positioning of the elements. That is, element 1 is at the index or position 1, 3 at 2 and 2 at the position 3, and the element 4 is positioned at the 4th index. So, if we need to access this element 4, we will specify it as B of 4. This will access the element 4. Same way, if we need to access 2, we will specify it as B of 3. If you want to access the element 1, we say B of 1. If we need to access the element 3, we specify it as B of 2. Let's verify this. So B of 1. So the element at position 1 is 1. So you can see your output here. Same way if I say B of 2. You can see the element 3 is accessed. So this is the B of 2. Same way if I give B of 3. It is accessing the element 2. So B of 3. B of 3, that is the element at the position 3. That is nothing but the element 2. Same way if you give B of 4. It will access the element 4 which is at a position 4. So here also we can make use of the colon operator to access multiple elements of your array. So if I simply give b of colon, this will access the entire elements of your array. So you can see 1, 3, 2, 4. It is accessing the entire elements of your array column wise. So one more example, if you give b of 1, 2, 3, it will access the elements from the index 1 to 3. 1, 3, 2. The elements from index 1 to 3. So 1, 2, 3. The elements 1, 3, 2 are accessed here. So that's about linear indexing. Using true and false logical indicators is another useful way to index into arrays, particularly when working with conditional statements. For example, say you want to know if the elements of a matrix A are less than the corresponding elements of another matrix B. The less than operator returns a logical array whose elements are 1 when an element in A is smaller than the corresponding element in B. Okay, let's create A first. Say A is equal to, so A is a 2 cross 3 matrix. Let's go ahead and create another matrix B. Say B is equal to, so this is our B, another 2 cross 3 matrix. Suppose if I write a statement I is equal to A less than B. Now that you know the locations of elements meeting the condition, you can inspect the individual values using I as the index array. So how did we obtain I? By checking the condition A less than B. So how is this checking the condition? The first element of A is taken and compared with the first element of B. So wherever the relation is true, it returns 1, else 0. So it is checking 1 less than 0. The condition is false, so it returns 0. Again 2 less than 3. The condition is true, so I'll get 1 here. Same way 6 less than 7, condition is true, I'll get 1. Again 4 less than 3. The condition is false, so I'll get a 0. 3 less than 7, condition is true, so 1. 6 less than 5, condition is false, so I'll get a 0. So this is how I get my I. Now from this, I can access the elements that is remaining true in the case. Now if I write a command like A of I, Matlab matches the locations of the value 1 in I to the corresponding elements of A and lists their values as a column vector. So the true element are here. The matching element in the matrix A is 2. So it will access 2. Next is 1 here. The matching element in the matrix A is 3. So it accesses the element 3. And next true value is here. The matching position is here. That is, it will access the element 6. Let's verify this. So if you give the command A of I, yes, you can see the output is 2, 3, 6. So this technique of accessing the element is referred to as logical indexing. Like you have accessed A of I, you can access B of I as well. So this will access the elements of B that remains true in I. So it is accessing 377. So how you got this 377? So this is your B, this is your I. The true values of I are what? Here you have a true value. So the matching element at the position of B is 3. Again you have 1 here. The matching position is here with the element 7. So next is 1 here. Matching position with the element 7. So this is how you got the output as 377 when you give the command b of I. Same way you can access the false value also. So if you have given like b of negation I, this will access the false values from the matrix I. That is, wherever you have 0, the matching position will be accessed. So you will get b of negation of I, you will get the output as 0. Next, the 0 value is here, the corresponding element is 3. So you will get 0, 3. Again you have 0 here, the matching index is here with the element 5. So if you have given b of negation I, your output will be 0, 3 and 5. Let me show you an example where you can make use of this logical indexing technique. Say you have a matrix A with the elements as shown, and you need to pick out only the even elements of your matrix A. So how do you check a number as even? You divide the number by 2 and check for the remainder if it is 0. So same logic we'll apply here. You can make use of the Matlab function rem to get the remainder of a number. So if I say rem of a comma 2, it will divide each an element of your a by 2 and the remainder will be given. So I have to check if this remainder is 0 or not. So I'll use a relational operator equal to check whether the remainder is 0 or not. Let me take this result to a matrix B. So you can see the output here. Wherever the remainder is 0, it is returning 1, else it is 0. So to pick out the even number of my matrix A, I will access the true elements of B. So if I say A of B, I'll get only the even element of my matrix A. So this is one application. So this is about the array indexing techniques in Matlab, the 3 approaches: subscript indexing, linear indexing and logical indexing. Thank you so much for watching. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get notified whenever we upload our new videos. Thank you.